For day 7, we're going to focus on systems from word problems, and we'll do more practice with elimination. Warm up. Draw a graph for each of these situations. So we talked about these in the previous section, how when you have two lines and I'm asking you to find a solution of the systems, we're looking for where did the two lines cross. So in graph number 1, if I want one solution, what does that look like? Well, it means that we have two graphs, linear graphs, so we're talking about straight lines right here, and we're looking for where they cross. All right, so what would the solution look like when you solved it? It would be one coordinate point. It would be an x value and a y value. So that is what one solution looks like. If your graph has no solution, then we talked about how that could be any set of lines that are parallel, because parallel lines, parallel lines have the same slope and they will never cross. So no solution. Again, parallel lines. It says what the solution will look like when you solve. If you're using elimination, you'll get 0 equals not 0. And that would indicate that, hey, these are parallel lines. They will never cross. There is no solution. And then we talked about infinite solutions, what that looks like. And that is when you have a line and the other line is actually the same line. So if they are the same line, you have infinite solutions. And again, how can you tell that? Just by doing elimination, you will get 0 equals 0. And that indicates that, hey, it's the same line, you have infinite solutions. So our goal today is we are going to practice elimination again. And we're also going to practice defining our variables and setting up equations from word problems. And then your assignment today, it has you define variables, set up equations, and also solve. So here's the first example. A park charges $10 for adults and $5 for kids. How many adult tickets and kid tickets were sold if a total of 548 tickets were sold for a total of $3,750? All right, so we have two variables. We have the adults and kids. You can use A and K. I'm just going to use X and Y because for me that's easier. So we'll say X is the number of adult tickets, and Y is the number of kid tickets. Okay, so that's defining your variable. In Delta Math, it'll ask you, it'll say, what's your variable? What does it stand for? This is what they want. Then it will say, write your system. A system is two or more equations. So we're looking at different things here. We're looking at the amount per ticket, and we're looking at total number of tickets. So the two equations will look like this. One equation, it is $10 for every adult plus $5 for every kid. So the total amount, again, we have two numbers here. We have total number of tickets, but then we have the amount of money. So this equation stands for money. $10 for every adult, $5 for every student, and that equals $3,750. So that is like the amount. Then we have total number. So I'll say this is the dollar amount. There's the equation for that. And then we have like the total number of tickets. And here we have adult tickets plus kid tickets equals how many tickets? So total 548. All right, so that is your system of equations. Sometimes you'll see this little curved bracket around it. Sometimes you won't. But that is your system, two or more equations. Now we're going to solve our system. We could graph it. We could use substitution. We could use elimination. And since I said this would be a review on elimination, that's what I'm going to do. So I'm going to choose one to get rid of. I'm going to choose to get rid of the y's, the 5y and the y right here. So I know that both 5y and y, they go into 5. And so I'm going to multiply my bottom equation by -5, and I'll just rewrite it. So my top equation, I'll try to write smaller here, 10x plus 5y equals 3,750. In my bottom equation, I'm going to distribute to everything. -5x minus 5y equals, pull up my calculator here. So I have -5 times 548. And I'll multiply that, and I'll get -2,740. Okay. Next step, we eliminate, and I chose to get rid of the y, so notice they cancel because they match and one's negative. So now we'll combine like terms. 10x minus 5x is 5x equals 3,750 minus, 1,010. To get rid of the 5, we'll divide each side by 5. And we'll get 202. I guess I could have done that without a calculator. All right, so X is 202. So what that means is we sold 202 adult tickets because X is adult tickets. So then we got to figure out how many kid tickets we sold. So we can choose either one of our original equations right here, top or bottom. I'm going to choose the bottom equation in green because the numbers are a lot smaller. So we have X plus Y equals 548. Oh, but we know what X is. X is 202. So I should have written 202 plus Y equals 548. And then we solve for Y. So we're going to get rid of the 202. It's being added. Let's subtract it from each side. So we get Y equals 346. All right, so we have 346, and that was kid tickets, and 202 adult tickets. And if we wanted to check our answer, we could plug those into the top equation in black, so I'll quickly do that. I will do 10 times the amount of adult tickets, 202, plus, parentheses, 5 times 346. Okay, and do I get 3,750? Yes, I do. So I did plug in and check my answer, and that is right. All right, well, let's just do a few more. Again, I'll show them using elimination. You could definitely graph it. You could definitely use substitution as well. All right, so example 2. The class president is organizing a class. Oh, we should talk about what this means. This means if we were to graph these two lines, they would meet at one spot, and they would cross at 202, 346. And you could graph it if you wanted to see it. All right, example 2, the class president is organizing a class trip to a nearby amusement park for 314 students. The regular price per ticket is $35 a ticket. However, some students receive a discount for doing community service, and they would only pay $21.50. The total ticket price, or the cost, is going to be $10,072. Okay, that's it. First step, define our variables. We'll say X is the number of regular tickets. I'll put hashtag, but I mean number of. Y is the number of discount tickets. All right, let's write our two equations. Okay, I'll do the first one. Okay, so there's two things we're looking at here. Money and number of tickets. So first I'm going to do number of tickets because it's number of students. All right, so X plus Y. So the regular price tickets plus the discount tickets total, there's 314 kids going. But then with the amount, how much was it for a regular ticket? $35 for a regular ticket, $21.50 for a discount ticket. In total, the total amount of money was at $10,072. Okay. Again, you could graph this. You could definitely use substitution. That might actually be faster in this one, but I will show you the elimination method. So first step, pick one to get rid of, X or Y. And since Y is a decimal, I'm going to get rid of the X. So I have to figure out what to multiply by so that X and 35X match, and one is positive and one is negative. Now, if you notice, X is positive, and I want to change it to 35. So what I'm going to do is I'm just going to multiply this top equation by, whoops, this doesn't like that, negative 35. Because if I multiply it by negative 35, then our X's will match, but one will be negative. So I'm going to go ahead and distribute this to everything, and I'll rewrite it over here. Negative 35X minus 35Y equals whatever 314 times 35 is, which is negative 10,990 is what I got. Yes. Okay. My bottom equation I didn't change, so the one in pink, I already had the 35X. I didn't need to change that. 35X plus 2150Y equals 10,072. No, 10,000. Yeah, 10,072. 720. Okay, so now we can add them together. And as we wanted, our X's will cancel because they match and one is negative. Let's put together Y. So I have negative 35 plus 2150 is negative 1350. And negative 10,990 plus 10,072 equals negative 918. Oh, and I forgot my Y here. Okay, so I had negative 1350y. Okay, let me give myself a little more space here. Erase this. Okay, so now, how do we get rid of the negative 1350? We are going to divide. And the reason why we divide is negative 1350 is being multiplied to the y, and so to get rid of it, we divide. I know a negative divided by a negative is a positive, but I can't do this in my head, so I'm just typing in my calculator. And I get 68. Oh, that's not dollars. All right, remember what y stands for if you forget. It's right here. Y is the number of discount tickets. So let's figure out the number of regular tickets by plugging into one of our original equations, which unfortunately I erased here. But the equation that I would use would be this one right here. X plus y equals, it was 314. All right, so I'm going to plug into here. I'm just going to take 314 minus the y value, minus 68, to figure out how many tickets are left. And so X is going to be 246 regular tickets. And if you want to check, we can plug it into this pink equation. So I'll do that real quick. I'm going to do 35 times X, which is 246, plus, parentheses, the 2150 times the 68 discount tickets. And I should get 10,072, and I do. All right, so I just plugged in and checked my answer. All right, last example, and we'll take a look at what this will look like on Delta Math. All right, so example 3, a chemistry test is 20 questions. The test format uses multiple choice, and the multiple choice is worth 4 points each, and the problem-solving questions are worth 6 points each, and the test has a total of 100 points. How many of each type of question is used? All right, so first define our variables. So we have multiple choice questions. I'll just call those X. X will be number of MC, multiple choice questions. And we'll say Y is the number of problem-solving questions. I'll put PS, questions. Okay, so we have X and Y. And then we have two types of equations. One is number of questions, and one is number of points. All right, so the number of questions, there's 20 questions. So I can say X plus Y equals 20. The number of multiple choice questions plus the number of problem-solving questions is 20. And then the next is the point value. I know the test is worth 100 points, but it's 4 points for every multiple choice question. It's 6 points for every problem-solving question. In total, that's 100 points. So this is my system. All right, let's use elimination. Again, you could graph it. You could use substitution, but I'll do elimination. Pick one to cancel. I'll just cancel the X's because the numbers are a little bit smaller, but you could choose the Y's. So we have to figure out how to make them match, but one should be negative. So I know I'm going to have to multiply the top by negative 4. And then my X's will match. All right, so I'm going to do my work over here. I'm going to distribute, multiply negative 4 to everything. Negative 4X minus 4Y equals negative 80. There's the top. The bottom I didn't need to change because I already had a positive 4X. Okay, so there are my equations. Notice we eliminate the X's. We'll combine like terms now. So negative 4Y plus 6Y, that gives us 2Y. Negative 80 plus 100 is 20. Let's divide each side by 2, and we'll get Y is 10. So there are 10 problem-solving questions. So the number of multiple choice questions, we have X plus 10 equals 20. I'm just plugging into the top equation. Subtract 10, most of you can do this in your head. And you'll see that, hey, there's also 10 multiple choice questions. All right, so your assignment today is on Delta Math. I'm going to just pull it up so you can see like what types of questions there are. So give me a minute. I'll have to log in here. Okay, and I'll just pull up like example problems that you'll see. Okay. All right, so this is the day 7. Okay, so just type of problems. Okay, so first you're going to have elimination problems, which is to solve. I would definitely do these on a separate sheet of paper, and you're going to type in your answer. Okay, so elimination. Okay, so here it is, writing systems of equations from context. All right, so in this example, it says, Jackson and his children went into a movie theater, and he bought $42.50 worth of drinks and candies. Each drink cost $6, and each candy cost $3.25. Altogether, he bought 8 drinks and candies. Write a system of equations. All right, so first you have to define your variables. We have drinks and candy. All right, so I'm just going to be X. You could use D, but I like X. Be number of drinks, and I'm going to let Y be the number of candies. You could choose D and C. You could use any letters that you want. You just have to remember what they are. All right, so X is the number of drinks for me. Y is the number of candies. All right, so the two equations, one is number of. So he bought 8 total drinks and candies. So I'm going to say X plus Y equals 8. So total drinks and candies, 8 total items. The other is money. So it was $6 for every drink. So 6X plus, and then it was $3.25 for every drink. Y, no, for candies, I'm sorry, candies, equals, and what was the total amount? $42.50. It's so expensive to go to the, wait, it's a lot. I wonder how many kids you had. All right, and then you can submit your answer. Yes, and then it will tell you if it's right or wrong. All right, so try these problems. And that is it. So again, your assignment is called Day 7. Let me pop it up. Day 7 elimination word problems and review.